Blended learning in the K12 classroom, meeting the needs of the above-average learner. What is the future of instructional design? The answer to this question may vary depending upon whom you ask. Most answers should include a recognition of the evolution of ID as a result of technological advances. No matter which model of instructional system design you choose, whether it be the Addy model, the Dick and Carey model, the Morris, Ross, and Kemp model, the Seals and Glasgow model, or some other model, you have to consider the development of instructional strategies, including how best to deliver the instruction. Tony Bates, in his book Teaching in a Digital Age, Guidelines for Designing Teaching and Learning, describes 3 modes of delivery, which includes classroom teaching, blended learning, and fully online learning. Bates describes these 3 modes of delivery as a continuum of technology-based learning. The diagram shows the continuum from face-to-face learning with the use of no technology to fully online learning using technology, and in between, blended learning that uses some technology. In today's classrooms, teachers face the challenge of trying to address the needs of a diverse group of learners. The needs of the weakest students are met with the help of instructional resource teachers, but no support is available to meet the needs of the above-average student. So what are the needs of the above-average student? Above-average students often finish their work early, need to be challenged or to become bored. We are holding them back when they could learn so much more. They are not meeting their full potential. So what is the solution to this problem? I wonder, could it be blended learning? So what is blended learning? Staker 2011 describes blended learning from a student's perspective as: blended learning is any time a student learns at least part at a supervised brick-and-mortar location away from home and at least part through online delivery with some elements of student control over time, place, path, and/or pace. Staker provides a visual comparison of what constitutes blended learning from other types of learning through what she calls a blended learning matrix. In the diagram, the gray area represents various levels of blended learning, while the white area, blue line, and red line indicate learning that is not blended. Staker describes 6 blended learning models: face-to-face driver, rotation, flex, online lab, self-blend, and online driver. The first article I reviewed, authored by White, Barnes, and Lawson, was titled Using Blended Learning for the Teaching of High School Mathematics. It describes the results of a study conducted at a large school in South Australia that had recently begun using blended learning. The school made a significant effort to develop an online presence for most of its subjects, including mathematics, to support student learning using a learning management system called Moodle. The study was conducted over 3 consecutive years, 2011 to 2013, during which students were asked to indicate their thoughts about how useful was the use of Moodle and to comment on how it could be improved via an online survey with over 70% responding each year. Their findings can be categorized under 5 themes. Access to materials. A majority of students felt that access to materials outside of class was much easier. Extension of learning. Some students reported that they were able to learn beyond what the classroom demanded of them using online learning programs like Maths Online. Flexibility of learning. Students noted that they were able to catch up on what they missed when they were out of class because they could access the materials outside of class. Review purposes. Students felt that the posted lessons helped them review the material from that day at night while at home. As well, students liked the use of online sites like Maths Online and Khan Academy for review purposes. Improved understanding. Students indicated that they were better able to understand the material when blended learning was used by accessing alternate explanations, interactive learning objects, and tutorial websites. The second article I reviewed, authored by Ballantine and Varga, was titled Attitudes and Achievement in a Self-Paced Blended Mathematics Course. It describes the results of a study conducted in a small suburban middle school in the Midwestern United States. The participants of the study were 23 high-ability grade 8 students enrolled in a pilot self-paced blended mathematics course. The goal of the course was to individualize the rate of instruction for each student. Along with the normal 5 days a week in a class, students were also required to complete at least 120 minutes a week of online work at home. During classes, students worked on objectives independently or in small groups using sample problems and instructional videos, received direct instruction or remedial help from the teachers, or completed assessments. Some notable points they concluded are: students who already enjoy mathematics will be more successful in a self-paced blended course than those who do not. Students who are especially interested, motivated, or confident in mathematics may see significant achievement growth in self-paced blended classes. Self-paced blended learning classes allow students to cover more learning objectives. Conclusion. Reviewing the articles has helped me answer the question I have posed. That is, can blended learning in my mathematics class provide the support needed by my above-average intermediate students? From the first article, I saw many benefits to using a blended learning model in my mathematics classes. I was particularly interested in the fact that some students indicated they were able to extend their learning beyond what was expected of them in class. The second article I reviewed provided me with additional support for my idea regarding blended learning. Based upon their conclusions, I can see that the answer to my question as to whether blended learning can provide the support for my above-average students would be a simple yes. Supporting this conclusion is the fact that some students were able to successfully complete up to 2 years of coursework in 1 year. This would certainly provide the best possible outcome any teacher could expect from their above-average learners, all made possible by switching to a blended learning design for delivery of instruction. So what's next? While conducting research for this paper, I found it difficult to find studies on the use of blended learning in intermediate or secondary school mathematics classes that could answer my question. I believe there is room for further research in this area, in particular more research that compares the achievement of students in a classroom that uses the traditional model of delivery to one that uses a blended learning model of delivery as needed. The research might also help transform K12 mathematics education as we know it today and help the process of instructional design evolve to include more blended learning.